Hey everyone, hello. So I have been actually thinking of starting to make videos on machine learning applications, data science applications in marketing. Quite a few people had already told me that I should start doing that, and so this is going to be my first venture. Um, and I hope this comes out well. So first things first, obviously I'm going to talk about RFM and customer lifetime value. I'm going to use Python code for this. But yeah, a couple of disclaimers right at the start. This is not a code that I have written from scratch, not at all. This is actually taken from the internet. Someone has written the way, most of the logics behind it. What I've just done is that that was written for a Jupyter notebook, so that's a specific kind of Python environment, very commonly used. But I prefer something that's cloud based, which you can run on the net instead of running on your computer. I have seen from my personal experience, Jupyter Notebook is great, but I mean, among Python fans, the opinions are very strongly divided. But I'm not going into that because this is for the marketing community, and this is primarily for those who are looking to get started. And so I use Google Colab. This is something that I'm more comfortable with, and I'm not going to go into the debates of Jupyter Notebook versus Colab. But yeah, I had to tweak the code a little bit. That's why I pointed it out. The initial code is already there. The examples are already there, like I've mentioned in the LinkedIn post, as a response to which I'm obviously making this video. And I wanted to really show the power of data science and machine learning. And we obviously do Google, this kind of analysis like RFM and CLTV in Excel, in Google Sheets all the time. And they're very powerful, by the way. By no means I'm suggesting that these tools are not powerful. They are actually super power. They're super powerful. They're powerhouses, in fact. But what I'll definitely say is if you try to implement what I'm just going to show you in Python, and you try to replicate the same functionalities in Google Sheets and Microsoft Excel, you're going to see that it's going to end up being much more difficult. All right, and you have to be a super pro. There are obviously people who know that level of Excel and Google Sheets. It's going to be much more complicated than this. I can promise you that. Now, of course, it depends. There are different kinds of approaches to solving this. This is a very rigorous kind of exercise. This is not going to be a very simple video. This is going to be a relatively long video, so I just wanted to give you that heads up at the start. And I'm going to be making a series of other videos. There are obviously loads of other educational materials. You're obviously more than welcome. You feel free to go through all of that, whatever you like. But this is specifically for marketers, and I think this is what probably is a little bit missing, at least from what I've found in the content that is out there on the internet. Most of the discussions about even marketing analytics usually comes from the point of view of data scientists who will just just explain things in ways which will be a little difficult for marketers, or for even business owners who are trying to do their own marketing and marketing analysis themselves. It's usually a little difficult to grasp because data scientists come from obviously a very much more mature position in relation to data analysis. They obviously do it on a daily basis. This is their bread and butter. But for those who are uninitiated, I think it's a little better if there's a helping hand, and it's nothing better if it comes from a fellow marketing person like myself. I think that was my rationale behind it. I obviously do tend to use Python code and aspects of data science and machine learning from time to time as well, in my everyday work. Right, it definitely enhances productivity, and it has definitely given me a lot of advantage, and I think a lot of edge over a lot of peers because of this. And I definitely want to share that knowledge with the marketing community now, and so that others can also benefit from it. So without further ado, let's get into it. I hope that was clear. I will also share the link to the original resources. I will actually show all the inspirations and whatever sources I have taken information from. So I'll jump first into the data set. Okay, so like I said, what we're going to do here is do RFM analysis and customer lifetime value analysis. So this is the data set that I'm actually working with. So like I said, everything is available in the public domain. This is on the site called kaggle.com. Anyone who's been into data science, done anything with data science, really just has any preliminary knowledge as well, will know about Kaggle for sure. This is the place to go if you're looking for code, if you're looking for data sets. And this data set is publicly available. This is an online retail data set, and this is the one on which we're going to do this analysis on. The reason why I'm using a publicly available data set is because it's a little difficult to explain for those who have not yet done advanced data analysis, but I can tell you this, and please, just believe me right now at face value, that you cannot do proper analysis and understand the implications of proper analysis when you are at a learning phase if you're working with very complex data sets, or with which don't have the capability to bring out the kind of patterns that you are looking for when you're trying to run certain analysis like RFM. So for instance, if you don't have too many repeat purchases in your data set, it won't give you much value, right? You won't be able to visualize and understand and fully internalize the significance of the analysis, if you know what I mean. So that's why the data set is actually very, very crucial. The data set that you're using will go a long way in establishing the kind of impact, in having the kind of impact the entire process of learning is having on you. So that's why I'm using this. A lot of people, as you can see, 54 codes here. In fact, other people have uploaded the data set. So the way Kaggle works is anyone can upload the data set. Anyone can engage in competitions. They can write code. They can share knowledge with the community. They can engage in discussions. So it's a very participative, very bright, and always buzzing with activity, basically, kind of online community for data science. It's specifically for data science. You can say it's kind of like Stack Exchange for data science, but I think it's, for me at least, it just looks a little bit better if you ask me. But anyway, without going into that, so again, this is a data set, by the way, which you can generate from your own data, right? So you can get the data on invoice number, which is obviously not going to be very important at the during the time of analysis, but you can always have some sort of invoice number, the product details, which is the product title. Then the most important things start, which is the number of orders or quantity. Then you have invoice date, or the date at which the transaction or the purchase was made, and then you have the unit price, which is at the price of the product, basically, at which the transaction was made. Then the customer ID, which is going to be the unique identifier for each customer. Obviously each customer ID is going to be different for each customer. And then the country. So the purposes of this analysis and the code example that I'm going to use, again, from the public domain here, and I'm going to just break it down, tweak it for Google Colab, like I said, and there's going to be a couple of other changes that I've had to make because the code was a little old, and certain things in Python have changed, so I've had to do those tweaks. But apart from that, I'm going to use the code which is already there in the public domain. I'm just going to use it for educational purposes. So do watch the video till the end. It's going to be a relatively longer video, but I can assure you that this will get you started. This will get you motivated to start working with data science and machine learning approaches. So yeah, let's get started. So like I said, for the purposes of this particular tutorial, we are only going to work with United Kingdom as the country, and we're going to focus now on the analysis. Now, so let's jump right into the Python code on Google Colab. So first we import certain libraries. Okay, so this is essentially inbuilt stuff from Python, and you need to import them so that you don't have to do all kinds of complicated stuff unnecessarily from scratch again. So the whole point of coding, by the way, and I think this is a very scientific way of doing things, doing anything, is not to reinvent the wheel. Okay, if it is out there, use it. All right. If you have to do something new, only then go ahead and do it. Now, for the purposes of learning, of course, you can do lots of complicated things. Like, for instance, there's a thing called neural network. It's very complicated for, I mean, from a beginner's perspective, but and there are very advanced uh, packages and libraries in Python. And I'm not going to explain the differences between packages, libraries, classes. That's not the point of this video, of course, like I said. Um, but yeah, these can just be directly loaded, which are inbuilt things, and then you can use them for your analysis. All right, but for the purposes of learning, if someone is very interested in machine learning and want to become a professional data scientist, they often do things from scratch. They don't use these inbuilt libraries. Okay, but that's a different exercise. We're not doing that. It's and the purpose is not to create a perfect model. The purpose is not to understand Python coding very deeply. The purpose is to just get it to work, to get the job done. And at a very advanced level, maybe you have to consult a data scientist, but at least you will understand the structure, and at a fundamental level, you'll be able to execute it just by understanding the fundamentals. But yeah, you have to understand Python fundamentals. So when I say that you are importing pandas as PD, understand that pandas is a very important library. You can actually just put your mouse over it. You can hover it over it, and you'll see that there's a module called pandas, and this is the name that you're going to give it, right, when you import it. So instead of writing pandas all the time, you can write PD. And then you have matplotlib, which is for plotting, as the name suggests, and within that you have pyplot. All right, and then you are naming it as plt for the purposes of this code, of this particular notebook. So like this, we have sklearn, again, very important. And from there you have matrix, and from there you're importing classification report and confusion matrix. All right. Then you have numpy, then you have seaborn, and sklearn cluster, which will from which we'll be using another very important concept in machine learning, and which will be used so frequently, which is called K-Means, which is used for clustering. It's a clustering algorithm basically. So this is, again, I've just installed Chart Studio, which is required basically for something that I will be importing next. So sometimes what you have to do is you have to import certain libraries from Python in order. You have to install them first, rather, before you will be able to import from them. So again, more plotting related importing done. And this is basically a machine learning model, which is a tree-based model. XGBoost, very powerful, and um, it's an ensemble model basically, and it's kind of similar to random forest, but considered more powerful and more suited for practical usage. Okay, and so we have sklearn.model, and from there you're going to import cross validation, k-fold, and trend test split. So these are all important concepts which I will be explaining as we progress in the code. So so now we are going to do the most important part, which is to start with. You obviously have to import the data set. So like I said, this is available in the Kaggle website. From there I just downloaded the data, and then I just basically um, you know uh, just uploaded it. Okay, so this is the specific way you can do it in Google Colab, and then you just um, you know have to carry out this part. Now let me just explain this a little bit. This was actually something that I had to do, especially I had to make this tweak in the existing code. This is because of the encoding of the data type. So UTF-8 it is a common encoding in CSV files, and if this is not present, then it's going to try a different kind of encoding, because if it doesn't recognize the encoding, then it will actually throw an error. So that's why I had to do this. This is called a try catch statement, or a try exception statement, and then it handles the exception by providing this alternative encoding, and then you just display the overall data, a part of it, by giving head. So for instance, this is dot head, and I can show it again, and like it shows 5, but I can show you 10 results, for instance, and then it's going to give you 10 instead of 5 results. Okay, so as you can see here, it's the same columns, but you're just getting a different set of a different number, a smaller number, because obviously you cannot see all the data points, right? So now we are going to go one by one into the EDA part. Okay, so we are going to understand the data better, and this is called exploratory data analysis. And this is a very important part of the entire process, because you're going to try and understand what the data really means, and if you have to make any kind of small tweaks to the data set in order for the analysis to be possible and for it to make sense. So there are certain things that you need to do in Python. That's the peculiarity of any programming language, and in this case Python. So you have to convert it into something called a date time format in Python, and then you can do that by using this particular thing. So on using pandas, you use to date time on the invoice date column in order to transform it into the date time format. So once that's done, then I'm describing the entire invoice date column again, and I get a lot of different kinds of values. So I get the maximum value, the minimum value. So for instance, the maximum value, which is going to be the most recent date, right? That's the maximum date. So that is the 9th of December of 2011 in this data set, and the minimum is the oldest one, right? So that's the 1st of December 2010. So the range is between these two, right? And then you also have the different percentiles, so 25, 50, and 75 percentile dates. But we probably won't be requiring that as much. So now we have a data type, and we are trying to understand the data type of it. And the data type is important, because the reason why I did this is because I wanted to understand if it has the right data, the right data type that I would be requiring to work with it. So it has the date time 64 or date time format, which is what we try to do here, right? Just confirming it basically. And then we try to do a query. So this is like a SQL query, where we just tell that, okay, we are only going to work with United Kingdom. All right, so the country is equal to United Kingdom, and then we actually save that in a new data frame called DX UK. So data frame is essentially is kind of like a tabular format of data. Again, I'm not going to go into the details of it, but this is essentially a data frame. So when I actually did this, just a second here. So yeah, I mean, when we actually imported it in this way, when we actually imported it in this way, we essentially converted it into a data frame. All right, the CSV file was converted into a data frame. So now we have created a new data frame, and this is where we are just selecting the country UK. And now again, we're just confirming the data type once more for a particular date. So what we're going to do now is essentially going to divide the entire data set into two data frames. All right, first will be a 3-month range, another will be a 6-month range, and I'm going to explain why. So the 3-month range will be the data frame over which we are going to calculate our initial RFM scores. All right, initial as in the RFM scores, and then we're going to extrapolate it to the 6-month data range. So it's kind of like using it to predict the 6-month data frame scores. All right, so yeah, so how do we do that? We obviously define the date range, right? So the 3-month date range is going to start from this particular one, which is the 1st of March, and then it's going to continue to the 1st of June, right? 1/6/2011. So these are the 3 months, and then you just include that in that, and because you have already defined the starting date range, so you just say that, okay, this is going to be less than the end date and more, greater than equal to the start date, right? Obviously, that's how you classify it, and then you have the new data frame for 3 months. All right, and then I'm just doing a customer count. Okay, and this is going to be important. How many entries are there actually in the 3-month data frame? And this is how we do it, dot count. All right, so this is how much we get, 71,683. Now this is interesting. This is, I've deliberately kept an error here in the code, and that's because I just wanted to explain why some tweaks may be needed. So this is basically part from the original code, and this did not work because, as you can see here, then this is, by the way, doing the same thing as the 3-month one, where we are trying to create a new data frame for the 6-month data, where we are trying to take a new end date and start date. All right, and this did not work because there's a problem with data types, and I needed to actually use it. So this is an invalid comparison, as it says, between date time and date. So it is using date time in this case, and because we had obviously converted invoice date into date time, if you would remember. There you go. And the date here is in a different format, which is why it's actually throwing an error. So what we needed to do is to convert it into a format called timestamp. And once we did that, then we carried out the same operation again. And this time, obviously, I've defined another start date and end date. That's why it's 2 this time. And once we have done that, we have the 6-month data frame created. And once again, I do a custom ID count, which is basically a count of all entries, right? Because custom ID is present in each and every entry. So this has a much larger data number of entries, right? And that's expected because this is a 6-month data. So now what we do is we also do a describe over the, just to understand what the nature of the information is within the 3-month data set, particularly within the invoice date column. And this is what we get. So we get, this is again a confirmation if it was right, because it's supposed to start at a particular date and end at a particular date, right? So you can just confirm that. So the 1st of March and the maximum is the 31st of May, right? So this is not inclusive of the 1st of June. So this is the 3-month range within this data set. Okay, sorry. So now we move to TX user. All right. This is basically a new data frame, and all we are doing is we are taking the unique values of the customers. All right, the customer ID, and then we are putting it into this one. All right, and if you actually do, interestingly, if I just do TX user, just a sec. So what I'm going to do is I'm just going to do a quick count of the number of entries here. This is going to give me a count. And as you can see here, the number of unique entries are much lesser, right? And that's because each customer has made will be appearing multiple times in the data set, right? Because if you look at the original data set again, and this is very important to understand. So the for each and every transaction there is an invoice code, there is an invoice number. So as you can see here, the same customer ID might get repeated. All right, and and so they have made multiple purchases, right? So that's why once you create unique customer IDs, you're just collapsing all of that into one, right? All the transactions by the same customer are being collapsed together. So that's what we basically did here. This is not really required, but just wanted to show you. So the TX user then contains unique customer IDs. Then we do our main process. This is where we have done some initial EDA. By the way, I've taken this from Kaggle. If you, like I said, and if you want to see other kinds of coding approaches, there are plenty of ways you can do this. All right, different kinds of exploratory analysis can be done, and this in particular is a very, very good data set. You can actually work with it really well in different ways. And in this case, we have only worked with the United Kingdom. You can actually take any other countries, and you can actually incorporate the country as an important information within the data set as well. So I'm going to continue our discussion on RFM then. So the first component of RFM is obviously recency. Then there's frequency, and then there's monetary value. I'm not going to go into the details of that because as marketers you should be already aware of that. But if not, feel free to also look at my other posts on similar topics. So recency is now in order to do that, first we're creating another data frame, and here we are just grouping by customer ID, invoice date, and then we are taking the maximum value of it, right? So essentially we are looking at all the customers, and for them, what is the recent purchase date? All right, so maximum invoice date means the most recent purchase date. So that of course is an important starting point, right, for getting to the recency. And so now we have a couple of columns. We are putting in two columns within this particular data frame: customer ID and max purchase date rather. So max purchase, and we are now trying to see what is the recency. So we are actually trying to create a new column within this particular data frame, and this is being calculated, and this logic is very important. We are basically subtracting the purchase date from the latest purchase date in the entire data frame. All right, so that means that we are subtracting from max to the number of days, which is the so this basically takes out the number of days. So we are basically taking a difference between the number of days, basically. All right, from the maximum purchase date, which is the latest, um, you know, from to the date of the actual purchase for that particular customer. So basically this is two timestamps. So just to make it easier for you, I've just broken it down into a couple of parts here. This is not actually required, but I've just done it for simplifying purposes. So timestamp for max purchase date dot max is this, right, which is 31st of May 2011. And then you also are trying to then this is creating a list of the data, essentially, from just getting the data, retrieving the data from the recency column, essentially. So for the first one, so for instance, for the third one here, so this one here, so recency is 21, right? So that is essentially telling me that it's 21 days from the maximum or the latest date of purchase. All right, so the latest date of purchase is the benchmark, all right, from which we are calculating recency. And I can show you that, because for one you can see it's 0, right? And for one, as you can see here, the timestamp is 31/5. All right, and if you look at the max purchase date max, you'll actually see that it's the same. All right, so 31st of May is the latest entry, the latest transaction date in the entire data set. And for this particular entry, for this particular customer, it is the same date. So that's why it's 0, right? Because you're subtracting the same thing from the maximum date. So I hope this is making sense. This is how we are calculating recency. Very simple logic. Again, this would be easily done on Excel as well. So we haven't yet reached that point which cannot be done in Excel, which cannot be done in Google Sheets, right? So we are still doing things which are relatively easy, but I'll show soon why doing this in Python is actually much better. So these were just for explanatory purposes. Now we are again updating the TX user data frame, and this time we are actually merging two things together. All right, so we are merging the previous version of TX user, which simply had a couple of columns. So that only had customer ID, in fact. And now on top of that, we are also adding from the Tmax purchase couple of columns which has customer ID and recency. So if we now look at the TX user head, we'll see that it has the customer ID and recency. All right. So when you merge on, and I will just try to explain this because we will be needing this in future code in this lecture. You'll see that customer ID is how we are actually doing the joining. So this is on which we are making the join. So this is the like the key. This is very much like SQL, by the way. SQL or SQL works very much like this. So you are doing the merging on the basis of customer ID. So the same customer IDs from these two data frames, TX user and Tmax purchase, they will be taken, and then the other columns will be just filled up. All right. So customer ID and recency is what you have then with TX user. And all of this is actually important. The reason why we are doing this is because we are trying to get to that point where we are able to do the plots and we are able to actually do our final clustering on the basis of recency, right? We have to create clusters, right? So just coming to that point, so we have now the TX max purchase as well. So I'm just trying to show you what these two, how these two are different. So TX user now contains customer ID and recency. TX max purchase, which is where we were, putting in the latest transaction dates that contain the dates as well. All right. But the point is, we don't actually need the dates. All right. That's why we only needed the recency. We just need a marker. All right. Using the dates. We don't really need the dates. We don't want to work with the dates finally. We just needed to do that for the intermediate calculations. So that's why this is not the final one. The one which we are going to go ahead and use is TX user, which just contains the recency column. We just didn't need this max purchase date column anymore. So now I'm also doing a describe again. So describe gives me all these, measures of central tendency. So count, mean. All right. So what does it tell us? So it tells us that customer ID's mean doesn't make any sense. All right. So you obviously have to apply a bit of logic here when you're looking at the data, but of course it does make sense to look at recency. So the minimum value of recency is 0. Like we already saw that, right? For the entry 1, we just saw that there was a recency value of 0, meaning that it actually equaled the latest transaction date. So similarly for maximum is 91. So the transaction, the recency value ranges from 0 to 91, means that with respect to the latest date of transaction, dates of transaction vary from 0 to 91 days. All right, I hope that makes sense. So now we're going to do the plotting. All right, I'm not going to go into the details of the plotting code. Honestly speaking, I don't remember the plotting codes very well, to be honest. I find them relatively easy, but there can be many complex ways of plotting them. And honestly, I just look up on the net and look up on the documentation, or maybe even refer to ChatGPT for it. But the idea is to do the visualization properly, because visualization is super important. But the concept is very simple. You just import the right libraries, and then you make subplots. So subplots means that you will basically get multiple plots within the same plot. So in this case, of course, we have only one plot because we are just plotting recency. All right. And so as you can see, the title is recency, and we have one row and one column, right? So for subplots, we can actually have multiple rows and multiple columns. So for instance, in 2 or 3 rows, you can have 2 or 3 columns. So you can have like 6 plots in the same plot. That's why subplot is used. But in this case, we just have one. So this is how the recency plot looks like. So what does it really mean? All right. So this is the number, by the way. So this is a histogram. All right. So this is frequency. All right. How many times it has occurred? So you're looking at recency, and this is the number of days, right? That's how we have calculated recency. So 10 recency means that 10 days have passed, right? Since the since not past, but it's 10 days difference from the latest transaction date, and then it's 20, 50, 90. So obviously, as you can see here, most of the concentration is towards the more recent dates. I mean, that's expected. I mean, transactions which have taken far back than the most recent date are going to become lesser and lesser. However, there are quite a few in some cases. So you can just look at the plot and get a very good visual idea of the distribution of the recency of transactions. Now comes the part probably which is the first time we are encountering something to do with machine learning. All right, this is something that's it's doable, again, like I said, in Excel or Google Sheets, but it's far better here because the iterations that you're going to do, the way you can control it is far better. So for instance, what we are using here is a clustering algorithm called K-Means. and K-Means is just going to come up with the, it's going to tell you how many clusters to make, what is the optimal number of clusters to make, the naturally occurring clusters within the data set. All right. So it's going to do several iterations, and you can control the number of iterations here. That's where the algorithmic approach works, right? So 1,000 iterations, and that's why we are using something called a for loop. So it's going to do this for a range of 1 to 10. All right. And so it's trying to figure out how many ideally number of clusters should be there. So it's doing this for up to 10 clusters, and it's trying to figure out what it's going to look like. So what it's going to look like is, I'll just show you. So essentially it's plotting something called SSE. So SSE is the sum of squares of errors. So this is basically where you're trying to find out the level of accuracy. All right. So it's it's trying to see how close the different clusters are, or how similar they are. All right. And it's going to constantly do these iterations. That's why it's doing 1,000 iterations. So on the recency data on which it is fitting, it's going to try and see what is the best number of clusters at which there's going to be the highest amount of similarity among the within a cluster. All right. So if a particular item so it's going to constantly try to improve upon the clustering. If there are still items which can be included within a particular cluster, then it's going to do further more further iterations. And then it's going to calculate the errors. All right. So what is the error, what is the how better it could have been, honestly. All right. I'm not going into the math part of the errors yet. You can calculate sum of squares of errors. You can in different ways. So it's essentially difference between prediction and the actual value. And then you take the sum of squares of it. So this is how the plot looks like. So this is errors for you, and this is number of clusters. All right. So when you have only one cluster, for instance, you have the highest error. All right. So these errors are decreasing, and this is basically called an ancient the elbow graph. I mean, you're looking for an elbow, which is basically an optimal point. All right. Beyond that, you don't really need more clusters. So this particular algorithm, I mean, visually we can see that it's actually 4. All right. It tells us that after 4, it doesn't make a big difference if you increase clusters, because the number of the errors are not decreasing. The error quantity is not decreasing, the SSE, as much. All right. So it's plotting the SSE over the number of clusters, and we see that beyond 4, it's not very meaningful. All right. So I'm actually taking some time to explain each of these points. It's going to become faster later on, but please bear with me. So again, then we do then we do again K-means for 4 this time. The previous one was an exploratory one, and this time we're going to use it for making predictions. All right. So we're going to predict the cluster for each user. That's the whole idea behind it. All right. So based on the recency, we're going to use K-means to predict their recency cluster. All right. So when we do GroupBy, just to let you know, GroupBy simply means that it's kind of like a filter. So you're applying you are basically looking at data for recency, and then you are just grouping. All right. Not filter, sorry, it's actually sorting. So you're just sorting by recency cluster, and then you're looking at the data for recency. That's essentially what it is. So that's why recency cluster is sorting, and recency is the data that you're looking at. And on top of that, you're also applying a function. See, these kinds of things can be done in Excel as well. But the thing is, it's just so easy in Python, right? You just write a small piece of code to do this kind of stuff. So you have again the modes. I mean, the different measures of central tendency. You have the mean. So you can see here the different recency clusters now. You have mean 8.31 for 0 cluster. For 1 it is 50. So it's obviously different kinds of means here for the different clusters. All right. And you have different number of and you have different number of entries for each of them. So just to understand then, so what it means, recency cluster 1 then has recency values which range from 50 to 63. All right. uh, a cluster 2 has values which range from 76 to 91. Okay, so that's how the clustering has been done, and this is based on an algorithmic approach, by the way. All right, if you had tried to do this clustering, if you had tried to think of it in a naive way, as it is called in data science or machine learning parlance, um, instead of an algorithmic way, what you would have done is, if you would have looked at the spreadsheet with the recency columns, and then you would have said, okay, why not just have 5 clusters, and let's define these clusters as this. So it would have been based on intuition at best. Sometimes intuition can be good, but when you have a large data set and when you have complexity in the data set, as in this case, and which is often the case in real world scenarios as well, it's not a good idea. All right, it's always better to fall back on algorithmic approaches. So now we actually, once we have the recency cluster, we're going to do a very important thing, and this is called the order cluster, and this is going to be actually used for for frequency, as well as for for monetary value, as well as for what is called the overall segmentation. Right. So we were just discussing recency, and we were towards the end of it, and we can see that we are using a custom function here, and this custom function is going to be used. I'm not going into the details of how the custom function really works. If you want, you can just get in touch with me. There's a lot going on in here, but this is just trying to come to a final formatting. Basically, it's just trying rearranging the data from the data frame that we have. All right, so just merging together bits and pieces of it. So once you call that function, you have the recency cluster, the recency, and then you have ascending as false. So what this is going to do is going to give you ascending false, means that it's going to give you in descending order, right? So you want the recency in descending order. So that's what the TX user data frame is going to contain. So now frequency is going to work in a very similar logic, except that instead of the actual uh, the the max date, which is what we were considering for recency, if you remember. So in case of recency, we were dealing with the max purchase, right? Because we were looking at the most recent date of transaction. In the case of frequency, we are going to just take the count, right? So we are taking invoice date, and we are taking a count, and we are just grouping it by each customer, right? So we are looking at each customer, and then we are just making a count of how many times they have made the purchases. The best way to do that is to do a count on invoice date. So the reasons we are having to do this is because this data is not going to come to you directly. If you take a data from a CRM system or from Shopify backend, stuff like that, places like that, you're going to have to run these kinds of calculations, right? So then we again create very similarly. I'm just going to do it a little faster this time, because it's a very similar kind of process that we did for recency. So customer ID and frequency are going to be the 2 columns now, and then we do a head on that just to see what we're getting. Similarly, we do a merge with TX user, and then we are also taking the frequency, data frames data, which contains the frequency. So all of these things are usually done just to make it easier to merge the data frames, and you obviously have to do the merging using a certain logic. So I was explaining the merging process in the last part on recency, when I said that you actually have to do the merging using a particular key. So the key is always customer ID, because you want the data for each particular unique customer, right? So the identifier or the unique key is always going to be the customer when you merge data frames. In some data frames, you're working with frequency. In some, you're working with the dates, and you just want to merge them together. So again, so what we are getting right now is we have got rid of invoice dates, and now we are working with only recency cluster, and frequency. So we already have the recency. So essentially on TX user, this is like our master data frame. We are just adding on new columns related to the RFM stuff, right? So we have already got 2 components now. We have recency, and we have frequency, and we have a recency cluster. But in fact, for frequency, we actually have to create the clusters, all right? Because just having a value, a numeric value, is not going to be enough. We actually have to create clusters on the basis of that, right? Because how do you make sense of you know 30 and 89? How do you differentiate? How do you know that what people to treat similarly? All right, so that's what segmentation does. So as you might have guessed, we are going to do a plot firstly to see frequency. So this is actually much simpler. As you can see, that most of the people are obviously clustered around a much lower number of orders, and that's expected, right? Not many people are going to make a huge number of purchases. So yeah, anything less than 1,000 has been given here because very few outliers are there. Outliers are extreme values. So most of the purchases are well less than 200 per customer. So all right, so that if we look at this particular data, this is very similar to what we did with recency. This is where we are using the K-Means algorithm to come up with a plot between the errors that is calculating, SSE, like I said, sum of squares of errors, and then it's seeing how it varies as we increase the number of clusters. So again, we are doing a very similar sort of code here, where we are doing this between a range of 1 to 10, and then we are seeing at what point the elbow occurs, like I was just mentioning in the last part, where the errors actually start, the decrease of errors just become insignificant if we increase the number of clusters. So that's your optimal point of choosing number of clusters. So in this case also the elbow occurs somewhere around 4. That's why we have given 4 here when we do our actual prediction on the cluster that the customer should be belonging to in terms of frequency. So a very simple code here again. There's nothing much to explain in these codes, and whenever I'm trying to explain any code, I'm doing that because there is usually something deeper to explain. But this is just mostly syntax, but I can explain it. I'll definitely explain in future videos more details of every piece of code, but I just want to ensure that you understand what is going on behind the codes instead of just explaining every single bit of it. So now that we have predicted, we are also showing this through our modes of central tendency, or different points that we want to see. So the frequency, and we have the frequency cluster. So for instance, we have 1605 in customers in the frequency cluster 0, and that has a mean frequency. So mean number of purchases essentially is 24 for this. Then the mean number of purchases is 496, 116, and 1364 in 3. So these are the different clusters means, and you also have the mean and max values for it, and you can just see how it is there. So so for instance, for 1364 there was only one value. All right, so that's actually been given a separate cluster. This can be questioned, you can say. All right, that should we be giving one cluster separately to one outlier? We can probably just eliminate that. All right, so that is just one thing. So I was just referring to how the models can be improved at the start of the video, right? So this is one thing, like we don't really need another cluster, and which might be actually explained a little bit by the graph, even if there's actually a decrease in errors or not beyond 3. But it does seem though that having 4 clusters does seem to reduce errors, and that's probably because the mean is the value is on the higher side, but it's something that we actually have to test, right? We have to go back and do this again. So this is something that that you can take as a homework for you if you're trying to follow along with this video. So then we, again, like I said, we had a function, right? We had described a function which was taking in 3 arguments: frequency cluster, frequency, or rather it was taking in 3 arguments, which was the cluster column, and then the target column. So the frequency cluster is our cluster column. We are basing it on the target column, which is frequency, and then obviously the data frame is tx user again, and it's in descending order. So we are calling that function again and again, like I said last time. Now we are moving to monetary value again. I'm going to pick up the pace again. It's going to do the same thing, only this time instead of looking at invoice date, this is going to be based on unit price and quantity, right? So we just multiply the unit price with quantity and we get the revenue. The revenue then is passed into the sum of revenue for each customer. This is very simple, right? So you want to get the total revenue for each customer, and that essentially is going to be your LTV, right? Over a period of time, you're just summing up the entire revenue that they've generated through transactions that you're just passing through into a new data frame, TX revenue, and then you just visualize it for the first few data points from it, and then you merge it again, just like previously with the customer ID, and then you do a similar process, a similar histogram to plot how many people have made transactions worth a revenue beyond a certain point. So this is how it looks like, right? So this is the number of people and this is the revenue, right? So as you can see here, beyond 2000 there aren't too many, and there's actually negative revenue. So this is possible because of returns, for instance. So some items may have been returned by customers, and most of them are, by the way, are clustered. So around much lesser revenue. So there's also revenue beyond below zero. So this is, by the way, a piece of code that I should have used earlier, just to show you ignore warnings. So all of these things. So Python, what it does is it when you run a piece of code, there might be certain things that are probably certain pieces of code that might not work. So I told you, right, I also showed you a couple of exams where the code which I'm using from the public domain, I had to tweak it in order to make it work, because Python has already changed certain aspects of its documentation, and it might not work anymore, will not work anymore. And similar things, they actually keep giving out these future warnings. So certain things will not change, all right, will not work, rather, they will change. So it's just giving out a warning so that it's just asking you to be aware of it so that you don't do it again in the future, because then it's going to throw up errors. But if you don't want to look at these warnings, of course, it can be pretty annoying, it can be distracting. So you can just run this small piece of code here: import warnings, filter warnings, ignore. Again, just the syntax, but you should know what it's doing, so that next time when I actually run this this plot between the errors and the revenue cluster, number of clusters, you see that the warnings haven't really appeared. So less annoying, right? Okay, so again, we again go with 4 clusters because the elbow seems to be appearing here. The error doesn't seem to be decreasing appreciably after 4 as the number of clusters. So again, we invoke that order cluster function. Again, we pass in revenue cluster, revenue, data frame, and ascending equals to true this time, by the way. So not every time is going to be false. So in this case, we want it to go from minimum to maximum. All right, that's how we want the TX user to be in this case. So all right, so you can actually see TX user after every operation. So you can see here it's the same data frame within which we are doing this operation, and then we are putting in revenue cluster and revenue, and we are describing how it is for each cluster. So the maximum value and the minimum value for each cluster, each revenue cluster is here. All right, so there you go. So now it's interesting to see here that you actually have negative values, right, in the cluster. So obviously this is something as a practice, what you can do is eliminate the negative values, right? So that's probably a good thing that's not been done in this code, but I think that's something that could be done because it doesn't make sense, right? All right, so now we go to the overall segmentation. What does it mean? So overall segmentation basically means that you club these different scores together, RFM. So it doesn't make sense to have different scores. You have to club them together. If you have gone through my Google Sheet template that I shared a few days back, you just try to get one column, and that was using concatenation, if you remember. And in this case also, we are doing a pretty similar sort of stuff. It just uses the plus as the operator, and then you just the different columns for each of the different clusters are just concatenated to get the overall score. You just add them up essentially. It's not concatenation in this case, you just add them up. In the example that I shown in the Google Sheet, it was concatenation. We were not really adding them up. So if it was, say, 0, 1, 2, all right, for the different clusters for R, F, and M respectively, using concatenation, it would be 0, 1, 2, all right, the RFM score. In this case, it will be 3 because you're just adding them up. All right then. And by the way, there's really no difference. You can go with either of the methods, whichever is easier. So now we group by three things. So we group by overall score. So we are looking at overall score, and we're looking at three things together: recency, frequency, and revenue. So we try and get an understanding of what kind of clubbing has been done. So you can clearly see that if your overall score is 0, then your recency is this, your revenue is this, and your frequency is this. So you get a good idea of the score. So not surprisingly, you see recency, frequency, and revenue. In 7 you have very low recency. You have your frequency is on the higher side as well. All right. So there you go. So with recency, obviously, the lower the value, um, the better it is. With frequency, the higher the value, better it is, and with revenue, higher the value, better it is. Right. So higher score has been assigned to the one with the best numbers. I mean, relatively the best number. So obviously, there's going to be some cases where the revenue is higher, but the frequency is lower. All right. So that's how that's the algorithmic challenge, right? And that's why I said that it's much better to leave it to the algorithm, because this is more complex to decide manually, because you're going to have to decide what to give the high score to based on three different parameters, and for each of the customers the three different parameters will have different values. So customer 1 and 2, for instance, between them, they may have frequency more in one case, and another one can have revenue more. But who are you going to assign the greater overall score, right? So it's best to leave it to the algorithm to decide that, and you actually have to choose the algorithms properly. That's the challenge of machine learning, of course, and that you usually do through measures of validation, that you do through measures of accuracy, and try and understand through scores of efficiency. Like I said, the score that I was just showing, not overall score, I'm talking about the SSE, which was the method in which to through which the K-Means algorithm is trying to find the optimal number of clusters. All right. So the SSE, the sum of squares, that has to be minimized in order for the K-Means to come up with the best cluster. So this basically is it. I mean, you are trying to you have got the overall score now, and you have got all the overall scores for the different the recency values as well. So this is just just I was trying to see what is the overall score for for the different clusters, the recency score rather for the different overall score clusters. All right, it's not the recency score, but it's actually the absolute recency value. Oh, I'm sorry, that's actually the count. Again, I correct myself again. So I'm actually looking at the count of recency for the different overall scores. I don't know why I did that, honestly, but yeah, you can do all kinds of stuff. So here now I have created segments. So this is again the next level thing. So you have got the overall score, right? But what good is that? You have to transform it into some kind of um, uh, string value or text value, or something that's easily understandable, right? So it has to be something meaningful. So saying that it has a score of 4 or 5 doesn't make sense. So what we do now is we have created mid value, high value, and low value. So it's a simple logic where if it's greater than 2, it's mid value. If it's greater than 4, it's high value. Otherwise, it's low value, right? So now again, we're going to do a plot. We're going to do a plot for all these three segments between frequency and revenue. All right. So that's what we're going to do. And we have just made a query that is going to be less than this revenue and less than this frequency, which is just to make the graph look better. All right. So we know that There's nothing going to be nothing beyond these, so there's no point taking in outliers if there are any, or unnecessarily making the graph look too wide than it necessarily should be. So all the information should be compactly visible within the space of the graph. So again, like I said, I'm not explaining this. Most of these graph plots, I mean the plot codes are relatively easy. You have the x-axis where you're taking the segment as low value and the frequency, and you're taking the segment as low value and revenue in the y-axis, and then you have markers. So it means that in the graph that's going to come here, these are going to be markers that are present. And then we are using the Go type of plot. By the way, if I just scroll up a little bit, you'll see that I had imported plotly graph as Go. So this is basically a plotly type of plot, and it is very useful, very nice to look at, and quite interactive also, as you can see. You get the definitions of these points with respect to the x and y axis. So that's what we have here. So the frequency versus revenue for the different segments, high, mid, and low. Very useful, right? I mean, you can see here clearly that most of the high segments, high means that high overall score, so high overall RFM score, they are, uh, you know, around frequencies between 0 to 400, because there isn't any higher frequency than that. And then you also have revenue. There are some outliers close to 35,000, but the high ones are obviously, as you can see, higher than the average, right? So most of the clustering, as you can see, is the green one. Not too many blue ones. It's only one, you can see. But most of the green ones have relatively lower revenue and relatively lower frequency, right? But the red ones, some of them are having higher frequency, and so that's the problem with Google Colab. It sometimes just disconnects from time to time. So anyway, so this says higher frequency, and some of them have also higher revenue, and that makes sense because they are of the high segment, high overall RFM segment. All right. Now we are going to do a plot between between recency and revenue, just like this was between frequency and revenue. So you can say in a way that these are our features. All right, in machine learning, the parameters that explain the output, they are called, the variables that explain the output are called features. So you can say that obviously frequency has an impact on revenue, or even if it doesn't have, I mean, you obviously just try to see. I mean, obviously it has in this case, in our case. But what I'm trying to say is you can always do the plots, and you can try to see the impact between an output variable. In this case, it's revenue or LTV, and one input variable or a feature. So another one from the feature set is recency, of course, and then we're looking at revenue. So looking at the different components basically, and plotting them against the revenue. So as you can see, very similar sort of plot like like frequency, where you have most of the high value ones. Obviously, they are very recent. The lower the data, the lower the recency, the better it is. So they're more recent. And the high ones, for instance, the red ones, are all clustered around more recent transactions, and they also, quite a few of them are in the higher revenue section as well. The blue ones, as you can see here, they are all within the they're not really recent, right? So they have much much larger number of days than the recent transaction date. And revenue wise also, they're not particularly high. They're all below the 5k line. So this is how you can interpret this graph. This is a very nice visual way of understanding how your clustering has been done and whether or not it makes sense, right? I mean, it's very important to see that. I mean, clearly the algorithm has done a good job of doing the clustering because it's very logical, right? And then we're going to do another one, and this time it's between recency and frequency. So this is between two features actually. All right. So how this is also working out. So we can see that the high value customers, for instance, the high RFM customers, most of them have recent transactions, and they also happen to have slightly higher frequency than the rest. Again, makes sense, right? So when you're even looking at recency and frequency, you can actually see uh, the logical outcomes. Now we are going into LTV. All right, so this is the most important. I mean, the next important part we have done. We are done with the RFM analysis, and now we are doing. We are left with the last bit of it, the last leg of the analysis, which is the lifetime value calculation. So we have the data set. So we have the TX user. We have been working on the same data frame. We have constantly, um, you know, uh, basically inserted the different columns with respect to recency, frequency, and revenue. And we also have the overall score. So this is the entire thing that we have. And if you would remember, we had done a separation on the overall data set between 3-month data and 6-month data, right? So the 6-month data is this, right? And we are just looking at the first 5 of it. And this, of course, looks very different right now, right? I mean, we have been dealing with very different kinds of columns. This is a different column set altogether. But this is the original data frame. So this is just TX just for the 6-month data. If you remember, we had just chosen the start and end dates to define 6 months. So now what we're going to do essentially, firstly, is for the 6-month one. If you remember, for the RFM analysis, we have not done the RFM analysis over the 6-month data, right? So we have only done it over the 3 months data. So what we're now going to do is essentially, first we're going to calculate the revenue, which is actually going to be the LTV in this case, because it's over 6 months for the 6-month data set, all right, for all the customers within the 6-month data set. And we're going to get the revenue for all of them. There you go. So we have all the customers, and then we have the revenue for all of them. And then we once again just take a quick peek at the data at the data frame, the 6-month data frame, and now we have the revenue column within it. And we then quickly do a histogram of the revenue as well, and we see that there's also negative revenue here as well within the 6-month range, and yeah, that makes sense. All right, and most of the revenue, as you can see, is towards the lower side of the revenue spectrum. So now what we're going to do, and this is important to understand, is we're going to merge the 3-month data set and the 6-month data set. And it actually took me a while to figure this out myself, to be honest. Initially I thought I've understood everything, and then it took me a while that, hey, why the hell, what we are actually doing here. So if you think about it, this can be entirely understood just by the logic of the code itself. So we are doing a merge operation, and this is why I tried to explain it earlier. And we are doing a merge operation on customer ID. Remember, so we are doing the merging on the basis of customer ID. Essentially, what it means, and it's very similar, like I said, to SQL queries. Um, when you do a merging on a particular column, it's like the key. It means that if you're doing the merging between 2 data frames, it's only going to take those entries for which the customer ID is the same. All right. So if there are customers, and there are going to be customers who are going to be in the 6-month data frame, who are not going to be in the 3-month data frame, they're not going to be included in this final merge data frame. All right. And this is very critical to understand. And this explains why we are doing the merging. Sorry. So what we are really trying to do here is we are trying to use the overall scoring patterns from the RFM scoring, the overall RFM scoring that we got from the 3-month data framework, and we're using that in the 6-month data framework. That is the whole reason why we had done the split in the first place. So it's kind of like predicting. It's not exactly predictive, but what we're trying to do is use that basically, because we have the revenue, right? We have the revenue now in the merge data frame, and in the 6-month data frame we also did that. And we also that's what's going to bring us to the LTV part, actually, essentially. So this is now the merged data set. So we have the cluster data that has come into it now, and we also have the revenue data, right? And we have the revenue data and the 6-month revenue data. So what we, so what I just try to do here is I was trying to find out, if there's actually any segment value, for instance, segment column value which is null, meaning that it doesn't have any value. The reason why I was trying to find out is, first I was a little confused. Say, hey, are there going to be customers who were not present in the 3-month data frame in that case there should not be any segment value, right? Because we haven't calculated the RFM scores for them. But then I figured out, okay, this is just doing a merge operation, and then it's basically done on the unique and overlapping customers. All right, so that's what it does. And then I actually confirmed it. Again, this is not going to be present in the original code. That's why I said I'm going to take the code, but I'm going to tweak it in my way in order to explain things better. So what I'm doing now is I'm taking the length of the TX user data frame, and I'm taking the user count of it, and I'm also doing this for the merged one, and then you see it's the same. So that explains what I was just talking about. So since you've done a merging operation, you will have the same set of customers basically, and obviously then the same number of customers as well. So now we actually fill in with 0 in case there is any data um, point within the merged data frame with 0. So what fill in a 0 does is essentially takes anything that does not have any value, that has a missing value. It's actually referred to as NaN. That's how it looks like if it doesn't have any value, like this, and then it's just going to put in 0 there. All right, that's how it's going to do. All right, and once it fills in the data with 0, and if whatever is there with that problem, and then we just group by segment. We look at the segment and we look at the revenue for each of the segments. All right, so this is the merged data set now, and then we're going to do a plotting again, similar plotting when we're going to look at the different segments, and this time we're going to look at the merged revenue and the overall score. All right, and this is a very, very useful piece of graph, a very useful piece of plot, where we are just looking at the different RFM scores, and we are also looking at the value, the revenue for each of the LTV, you can say, because like I said, I mean, if you're calculating revenue over time for the same customers, you're essentially calculating LTV. And then you have the 6-month LTV, and then you have them for the different RFM scores, and it looks so logical, right? So you have the RFM score 0, and it has as you can see here, the overall LTV is on the lower side, and it's also classified as low. On the other hand, if I look at the other extreme, the red one, which is high, overall score in terms of RFM scoring, the RFM scorings are also on the higher side as expected, and LTV is also on the higher side. So clearly, there's a clear correlation between higher RFM and higher LTV, right? So this was a very visual way, right? I mean, do let me know how you like this plot actually, and then we can do just redefine the merge data frame to only include those values which do not contain outliers. So this particular merging operation is done to eliminate outliers. All right, quantile 0.99 means that, and when we are doing taking only the values less than that, it means that it's only going to consider values which are less than 99%. I mean, it's only going to consider those values which are within the 99% of the data, essentially. All right, because anything beyond that is probably going to be outliers. And then we again do a K-means prediction. We have taken 3 as the number of clusters. All right, and once we have taken 3 as the number of clusters, we are going to do a presentation of our different clusters. All right, so here's what we have in terms of our LTV cluster. So these are clusters for LTV, by the way. So far we have been doing them for our RFM. This is for LTV. So 0 is the LTV cluster, and this is our mean, and this is the max. So you can see here, maximum number of people, obviously, a much more number of people are within a lower LTV. The max value is on the lower side, a higher max value, lower number of people, and the least number of people within the highest maximum range of revenue. So in the lowest revenue range, you can see there are also people who probably would have done refunds. I don't know, I honestly haven't gone in details within the data set. I highly encourage you people to do that, by the way, to try and see if you can find out more information about it. But yeah, I mean, there's negative revenue included in the 0 LTV cluster. Like I said before, this is not meant to be a session where I show you perfect code. I just introduce you to the code, to the concepts of LTV and RFM using machine learning, and I also show you to do it through Python code. But you can always improve it, right? So you can eliminate negative revenues if you wanted to. I mean, there could be use cases for doing that. Now I'm just creating a copy of the merged data frame, which is um, which contains this one basically. This is the LTV cluster, and what I'm no sorry yeah so this is basically the merged data frame, which was consisting of both the 3 month and the 6 month data, and just creating a copy of that, which is the TX cluster. So TX cluster is this, which is again like the same as the TX merge, so it has the LTV cluster and it has the different segments as well from RFM. So the reason why we have done this is essentially to create dummies. Now what we're trying to do is we're going to start doing a modeling, all right, and we're going to try and understand um, the performance of our model as well. And for that we are going to create dummies out of categorical variables. So in order to run you know most machine learning models, a lot of machine learning models, you have to create dummies out of categorical variables, because without that you're not going to be able to actually run the model. So for instance, by categorical variable I mean anything that says um, by categorical variable I mean anything that says that has a string or a text value as its input. All right, so you have to convert that into ones, or you have to convert that into dummy values essentially. All right, and once that is done, so that can be in the form of 1 and 0, by the way, and that can be also done in the form of true and false. All right, so it's just a binary value essentially. So segment, if you look at the previous thing here, so it was mid value, right? So if you look at this first entry here, which is for customer ID 14620, you will see that it was mid value, right? And see that it's false for high value, it's false for low value, and it's true for mid value, right? So what is often done, again, this is a possible improvement that can be done, is you actually don't need the segment mid value. You can only have segment high value and low value, for instance, because if it's false in these two cases, it has to be true for the third one, right? So again, I think this is an improvement that could be made on this particular code. But now we're towards the end, and we are trying to just look at the different LTV clusters, and going to look at the correlation with the different um, features, and as well as in certain cases outputs as well. So for instance, revenue you can say is an output, because we're trying to look at revenue as well. But so this is the correlation matrix, and the correlation matrix gives us one, of course, for LTV cluster, because that's what we are measuring the correlation against. And as you can see, it has a very strong correlation with revenue, as is expected, with the 6 month revenue, and also strong correlation with revenue cluster, like that. So this is essentially, the way we are trying to, the way we are going to try and predict LTV clusters for the customers, right? Because so far what we have done is assigned LTV clusters to the individual customers, and the model now is essentially going to be a classification model. All right, this is not a regression model, because we're going to try and classify, and then we're going to try and um, you know assign the right clusters to a particular customer. All right, and what features are we going to look at for making that prediction about the classification? All right, so we choose the ones which have the highest correlation from here. That's the overall idea. That's why you will see that M6 revenue, for instance, we have that's what we have dropped here, and we have also and that's why within X we have obviously dropped LTV cluster, because this is the feature set that we're going to use, and we have dropped M6 revenue because it's way too close related to it. We don't want that. and instead in Y we are going to use LTV cluster, which is what we're going to try and you know predict the classification for a particular customer. And then what we're going to do is train and test. So we have a training data set, and then we have a test data set. Okay, so X and Y are going to define our the train test split. So X, as I said, is going to be all the columns except LTV cluster and M6 revenue, and Y is going to be LTV cluster, which is our label or outcome column. And then the test size, essentially it's a a split. It's a 5% split between train and test. And yeah, that's pretty much it. So that's how we actually start with any machine learning model. We have to in many cases, at least, we do a trend test split in order to provide the machine learning with some training data on the basis of which it's going to work on the test data, and then come up with its output. So now we're going to run the XGBoost model finally. So XGBoost model is invoked by using the XGB classifier, because this is not regressor, we are doing a classification. And so maximum depth is basically of trees. It uses the concept of trees. So how many trees will it use at the maximum, for its purposes. So the trees, by trees I mean decision trees. So it's going to go maximum up to the depth of 5. So the depth of 5 is how many nodes will be there within a tree, right? So it's going to go maximum up to the depth of 5. And then it has a learning rate of 0.1. It's actually a hyperparameter, right? And again, there's actually a detailed math behind it. Initially I thought I'd explain all of this in one video, but I think it's going to become really long. I think it's already more than 1 hour now. So I'm going to explain all these things about hyperparameters in a different video, possibly, definitely in future videos. But for now, I've kept the maximum depth at 5 and the learning rate at 0.1, and then also provided other parameters, and then I'm going to fit it on the training data, xtrain and ytrain. And then I'm going to print the accuracy. Okay, so what is the accuracy of this model? And the accuracy on the training set comes out to be 0.91, and the accuracy on the test set comes out to be 0.75. It's expected that training set will obviously have a higher accuracy because you have already trained it with the same data, and it's predicting the LTV clusters on the same data set, and it's going to be obviously lower on the test data set. So here what we have done is the training and the test data set. We have used the 3-month data as the training data set, and the 6-month data set is the one on which we are doing the testing on, right? So that's how we have essentially done this, and we can do the so this is how it turns out to be. And if you want to look at the LTV cluster um, uh, you know distribution, um, with respect to the overall number of customers. So what this particular piece of code does is it's taking a ratio between the number of customers in each LTV cluster, and also the total number of customers. All right. So takes class.customerid.count means that it's the total number of customers, all right, in the data frame, and then you're also doing a customer ID.count for a particular LTV cluster. So 0.76 means that it has 76% of the total number of customers within this particular cluster, all right, and you can do LTV predictions using this particular XGBoost model, right? Now you can actually do several other things on it. You can do hyperparameter tuning, like I said. So there are many places where you can improve it. So learning rate is one. Then there are other places where you can do learning parameter, hyperparameter tuning. I'm not going into the depth of them. I'm going to explain each of those in future videos. But this was just to get you started. The number of the max depth actually. When it comes to the trees that are going to be used within XGBoost. So a lot of hyperparameters are there, which you can tune in order to improve the accuracy levels of the model. all right. And you can also change other things. For instance, in order to improve the model, you can um, uh, change the way the K-means algorithm was also working. So there are actually hyperparameters within the K-means algorithm as well. So for instance, if I just jump to this one, so how many iterations you're going to use, this is also something you can change. The more the iterations, the better it is basically going to be. I mean, there is there's a possibility up to a point. Of course, there are again threshold points beyond which it doesn't make sense. Just like I said for clusters, but usually higher iterations um, mean more computation space, by the way. So those are more advanced considerations, really. And when you professionally take up data science as a task, even as part of your marketing job as a marketing analyst, you will have to make those considerations. But for now, I think this is a good starting point. All right, and so we are at the end of our video. I'll just give a quick finishing touch to this entire discussion. So what we discussed is essentially how we calculate RFM clusters and then LTV clusters. We used primarily two machine learning approaches. One is the K-means clustering model algorithm, and the other is the XGBoost model. And both of these were primarily used for clustering. Obviously, K-means is a clustering algorithm always, but XGBoost can be used both for regression as well as for classification. In this case, we use it for classification because we wanted to get the LTV clusters and we wanted to predict which LTV cluster a particular customer is going to belong to. We found that the accuracy levels were pretty good from the model, but they can be improved by doing lots of things like hyperparameter testing, getting more features. All right, so that's another thing. Getting more features means how many features do you include in your analysis. All right, in this case, we include a lot of features, of course. As you can see, all of these are features. Some are pretty closely related to each other also in some cases, but we use all of these features, and we obviously dropped one. But yeah, if you have more things in your data set, in this case we only had the most basic ones which are required for RFM, like the dates, the number of orders, and also the revenue of the transactions. But if you have more information, for instance, then you can also include those in your data set, and it can make it more comprehensive. If it has more information, then it can make better predictions probably, and in that case the accuracy levels, the usability of the model is going to be better. So again, this is not my code. I mean, I've done some tweaks in order to explain, done some tweaks in order to run it on Google Colab or to make it work, because Python doesn't allow some aspects of the code anymore. But other than that, it's actually done. Uh, Somebody else have just taken it from Kaggle. You can look at lots of codes. All of these are available in the public domain, and different codes use different kinds of approaches. All right, it does not mean that you have to just look at this particular code. There are I've actually gone through several other code examples here as well, and all of them have their own positives and negatives. So whichever one you want to follow, you can just follow that. Right, I'll just open one or two more and I'll just give an example how many different ways these things can be done. So this is another example using the same data set, and I'm obviously not going to go through the entire code here, but you can see that it's much smaller. As you can see the output, and it's done by someone called Ronik Dedia, and you can see here similar sort of stuff is being done. Initially it's looking at countries, and it's actually dealing with countries, and it's looking at all country wise customer distribution. We only dealt with UK, if you would remember, in our analysis, and it's also looking at the prices, and so in fact it has in fact done that. It is only looking at United Kingdom, and it's similarly calculating the total price, which we are calling revenue, by multiplying unit price and quantity. Obviously it has to be done that way. And if we go down to the part where it's I see here min and max, it's defining it. It's also converting it into date time, and then it comes to this RFM table. So this is actually done in this fashion. So what it simply does, it uses the aggregate function, and it uses also something called the lambda, which is kind of like anonymous function sort of thing. where you just pass in the variable and you then define what actions to take on that variable. So this is something that cannot be used again. This is only for a one-time usage. That's just kind of function it is. So the invoice date, so what it does is essentially is for each customer it's going to do these aggregations, all right, and these aggregations have then been defined on each column. So on the invoice date column, this is the action that's going to be taken. What is that action? Just like what we it's a little different than what we did. It's essentially subtracting now. uh, Not really, it's actually the same thing. So now is essentially the date. It's passing a certain date, and then it's actually subtracting the latest transaction date from it, all right. So um, this is the date at which the transaction has been made, and then you're subtracting it from the maximum invoice date, which is the latest transaction date. It's the same thing that we did as well, just done in a different format. Similarly, it's trying to calculate frequency. So that's how it got recency, by the way. And frequency, it's basically taking the length of the invoice number column, meaning that how many invoices are there for each customer, you're aggregating it for each customer, like I said. And then it's obviously taking the entire length is simply the total number of occurrences, and meaning that it's getting the frequency of of each customer's purchases. And then it's the total price, which is just taking the sum of it, right? So it's taking X as total price, and then you're just calculating the sum of it, and that gives you the monetary value. So that's how it comes up with the RFM table here. Just a different approach, but the end result is the same. And so, like I said, I mean, different people are following different routes. It uses the RFM clustering. It does by using the quantile method again, and it comes up with three different quantiles: 25, 5, and 75. And then it says that okay, if it's less than 25, then it should be in 1. If it's less than 7, less than 50, it's going to be in 2. Less than 75, it's going to be in 3. Otherwise, if it's above 75, it's going to be in 4. So that's how the different recency score clusters have been done. So the more recent it is, um, I think, yeah. So if it's going to be in the top percentile, the top 25 percentile, it's going to be in the fourth cluster. I can see for the RS score one, and and then it's just calculating the scores, like I said, using quantiles. So then the segmented table is just applying the RS score, and then it's using the quantiles for each of the different parameters, components of RFM. So it's actually a similar method. It's just simpler. The code looks different, but it's kind of similar, but it does not use machine learning approaches. All right, so it does not use machine learning to come up with predictions for the clustering. So I would say that the one we have used is more comprehensive in that, because it's a more algorithmic approach. This is simple stuff. You're just doing this for, you're just simply filtering the data and coming up with your different clusters. That's all you're doing here to come up with the RFM scores. Right, so there you go. There's the concatenation again for you. And just, the R quartile, F quartile, N quartile are just connected, just joined together in order to get you the final RFM score. But I'd say that going the machine learning route is better, because that's going to give you more comprehensive analysis. So this one, for instance, has a huge EDA analysis, and definitely encourage all of you who are seeing this video to explore this if you're really looking to learn Python better. This is more focused actually on the country-wise analysis, as you can see here, and in fact by other aspects as well. So for instance, the lowest 10 products which are in loss, because there is also the product, things which we have not done dealt with, right? So in our case, we did not deal with other features like products. We did not deal with features like the country. All right, so these are features that could be included in the analysis, and there's a lot of EDA that has been done really well in this particular piece of document here. So this is primarily data analysis. This is not the same kind of analysis that we did like CLTV. So the same data set has been looked at by different people in different ways. I definitely encourage you to go through this. And of course, at some point, you will learn to write your own code. But honestly speaking, you don't have to become a Python maestro. That's not the objective at all. Um, I think as a marketing analyst, unless you want to become completely a professional data scientist, then it's another matter. Probably then you have to become a Python expert or an R expert. So yeah, I think this was pretty long. I hope quite a few of you have actually seen to the end of this video. I sure hope that you have liked it. Do subscribe to my channel. I will definitely keep producing more videos. I'll probably um, cut down this video into smaller parts, or if you, and in that case you're looking at the last leg of it, of course. Otherwise, I'll in my future videos I will upload more videos which are going to be shorter and which are going to explain um, more specific aspects of the process, but I just wanted to give you a holistic overview of the entire process. So I hope this was useful to you, and I really hope that if you have liked it, that you will subscribe to the channel and you will also share it, and yeah, just spread the word. Keep giving me the motivation. So thank you. Thanks a lot for staying with me.